Welcome to the video for Concept 4 in Chapter 3. In this lesson, we're going to be identifying rate of change. So first of all, what is rate of change? We know that the word change means, well, change, to go from one thing to another, okay? So something different is happening. And the rate means how fast that change is occurring. So we're going to define rate of change as how fast something is changing. So let's look here. Let's start off with this first one. We have the number of video games compared to a total cost. So our number of video games, this is going to be our X values because this is our independent variable. Remember, number of video games doesn't depend on anything other than your choice, how many video games you would like to purchase. But the cost is going to depend on how many video games that you purchase. So this is our Y value, or our dependent variable. And we're going to notice if there is some kind of constant change each time. So from 2 to 4, we have a change of +2. From 4 to 6, we have another change of +2. So it looks like so far we have a constant change on this side. Let's see what's going on the right side. Okay, from 78 to 156, how much of a change is that? +78. And then from 156 to 234, also a change of 78. So what does this mean? Yes, we have a constant change. Each time in our X coordinates, we're going up by 2, and each time in our Y coordinates, we're going up by 78. So let's write this as a sentence. There is blank for every blank. So we're going to, when we write this, we need to write our Y values at the top. And we need to put our X value change on the bottom, okay? So let's see. In our Y values, in our Y coordinate, we had a change of 78. Well, 78 what? $78 for every, let's see over here in our X coordinate, +2. So for every +2, what? Video games. Okay, in this table, we don't have our X and our Y coordinates labeled all fancy the way we did in the first one, but that's okay. We're still talking about X coordinates and Y coordinates, so we still need to find some rate of change happening in this table. Let's start with our X values. From 1 to 4, we have an increase of 3. From 4 to 7, another increase of 3. And from 7 to 10, another increase of 3. Okay, for our Y coordinates, -6 to -8. Think about this one for a second. If we're going even more negative, that means we're subtracting, we're going down. So this is going to be a -2, -8 to -10, -2, and -10 to -12, going down again 2. So here we do have a constant rate of change. Each time it's going up by 3, and each time over here we're going down by 2. So let's write this the same way we did before as a sentence. We have blank for every blank. Now this time we're not going to have labels because, like I said before, this is just an X and Y table. But let's put our Y's first like we have been, and the X on the bottom. All right, so let's write this. We have -2 for every +3. So if we were talking about our rate of change here, it'd be -2/3. Let's look at one more. Rate of change. Pay close attention to this one. We have -3 to -2. So if your negative number is getting smaller, that means we are increasing. We're going up on a number line. So +1. -2 to -1, +1, and -1 to +1. We kind of skipped a number here. We have -1 on a number line, 1 over here, but there's something here in the middle we're missing, and that's a 0. So to go from -1 to +1, we're actually going up by 2. This is not a constant change. Let's try this one. 11 to 15, it's plus 4. 15 to 19, plus 4. And 19 to 23, plus 4. So we do have a constant change over here in our y-coordinates, but we don't in our x-coordinates. So we cannot express this as a rate of change because it changes right here. Okay? So there's nothing we can do with this one. This is not a constant rate of change. All right, I want you to try the 3 on the right on your own, and let's flip over here to the next page. Okay, so now we're going to start looking at rate of change in terms of word problems, okay? In my first example here, I have a table that I need to read and then a few word problems at the bottom, and then we'll be done for today. So in our table, we have the Houston Astros ticket average prices, okay? So please pay attention when you're talking about tables. One of the most important things you need to notice are your units. So on our x-axis, we have the years, okay? And along our y-axis, we have prices, all right? Find the rate of change in ticket prices from 1996 to 1998. So from this point to this point, we need to find a rate of change. Now, you'd have to really kind of look closely to try to see where this point is between 8 and 12. But luckily, in this example, they actually tell us exactly where it's supposed to be. So we have a rate of change from this point to this point. We need to subtract these two numbers. And then for the years, for our x-coordinate, we know from 1996 to 1998, that is 2 years, okay? So let's write this as a rate of change. We have 1188 minus 1065 over 2 years. Okay, let's do the math here. $1. We're talking about money here. 23 cents for every 2 years. Normally with rate of change, we'd want to reduce this fraction as small as possible, but read the question. They want to know the rate of change in ticket prices from 1996 to 98, and that's a 2-year difference, so we can leave it the way it is. In 2 years, the ticket prices went up $1.23, so this is going to be our answer. I want you to try number 2 and number 3 on your own, but I'm going to skip to number 4 because I noticed in my graph that that is a rate of change that's going to decrease. From 2000 to 2002, let's look at our graph. That's from here to here. Ooh, yeah, that's going to go down a little bit. So I wanted to show you an example of one that goes, that decreases, okay? So we need to write our rate of change. Remember, your y-coordinates are going to go at the top, so our y-coordinates are going to be the difference between these 2 points, and always put your second one first, okay? So 18.87 minus 20.03. And we're talking in terms of money because these are ticket prices. Divided by how many years from 2000 to 2002? 2 years. Okay. So let's type this into our calculators. I'll give you a second. And you should get negative $1.16 in 2 years. So what this means is for these 2 years, from 2000 to 2002, ticket prices actually decreased $1.16. Not good for that ballpark. Okay, so try 2 and 3 on your own, and let's skip down here to some word problems. Let's try and find the rate of change for these word problems. Matt Forte, ooh, Chicago Bears, he's not with them anymore, darn. Matt Forte rushed for 120 yards on 30 carries. How many yards did Forte get per carry? So we have 120 yards per 30 carries, and we want to reduce this for how many yards he gets per 1 carry. How do we do that? Well, we need to divide 120 by 30 carries to reduce it as small as possible. Think of it like a fraction. Okay, so if we've got 120 yards per 30 carries, we'll put that into our calculator and do the math. And we'll get 4 over 1. So that means he gets 4 yards per 1 carry. Let's keep going. Number 2, 100 homecoming tickets were sold in 2.5 hours. How many tickets were sold per hour? Well, we've got 100 tickets per 2.5 hours. Reduce this as small as we can. So 100 divided by 2.5 hours, and we get 40 over 1. So that means 40 tickets per 1 hour. Okay, last one at the bottom. You know what? I'm going to have you guys try this one on your own. So I left you with, let me see here, these 2 word problems back here. Read the chart and answer them. This one on the bottom, which shouldn't take you very long at all, and then the 3 tables on the right side of the first page. So give these a try, and we'll go over them in class tomorrow like we always do.